I'm from Red Hat. I've been at Red Hat for 6.5 years now. I'm a software engineer there. Over that time, I've worked on a variety of different kinds of container tooling, originally in the area of delivering containerized content out to our customers and even internally. So if you've ever interacted with the Red Hat Container Registry, that was something that my team and I created. And then more recently, I've gotten into Kubernetes, of course, and orchestration. And I really just love the real-world containerized orchestration problems of getting stuff done. There have been some great talks so far at this conference even about some of those topics. So let's dive into some of that right now. I'm betting this crowd is fairly familiar with Kubernetes, so you're going to get the fastest summary ever. Kubernetes is, of course, a containerized platform for orchestrating containers across a cluster of machines of some variety. And then the other thing you need to know about Kubernetes is that it is declarative. So the whole premise, the whole way you interact with Kubernetes is based around expressing to it what you want the world to look like and then allowing it to reconcile the world to make the world look the way you want it. And the one example we'll look at is this YAML that you see here. This is our typical experience of interacting with Kubernetes. Here I've just created a pod, which is our primitive for running a service, running an actual container image in your cluster. And then we've created a service, which is the network presence for that pod. So this is much of what the Kubernetes-related tooling does is help you to maybe render these kinds of resources from templates, manage them, version them, and figure out how to use those to power your workloads and create your CI pipelines. Now, let's get into the good stuff. Chapter 1 is the MetaContainer as the app definition, which is kind of a lot of words, but we'll talk our way through it. When you're provisioning something, certainly in Kubernetes, but other systems as well, there are 3 levels of complexity that I think you can break down your responsibilities into. So the first one is you need to create a full stack of your cluster resources. So in our case in Kubernetes, that's some pile of YAML that defines what do you actually want Kubernetes to do for you. So for example, maybe you're deploying an application that has a database and an API service and then a front end. 3 separate processes that can run somewhat independently, but you need to stitch them together. You're going to create all kinds of primitives in Kubernetes that will express how do you make these things run and stitch them together and then keep them running. So once you've done that, the second level of complexity, a little more advanced, is integrating with external services. External services could include things like legacy applications, things that just aren't designed to run in your cluster maybe just yet. Things like a traditional database cluster, many people have a dedicated team that runs their database cluster in a high performance and highly available way on dedicated hardware, and they're not so interested in your Kubernetes cluster, and that's fine. And then appliances, of course, are another good example, common example of things. There's all kinds of appliances for management and email and DNS and firewalls and so on. You may want to integrate with those things quite reasonably from Kubernetes when you're deploying something. And then lastly, there's post-install bootstrapping. So what happens after your application is actually up and running? All these services have started, they're deployed, they exist in the world. You may need to initialize a database. You may need to do something like restoring from a backup, which we should all probably do more often than we do. And you then may want to create some resources inside your application. Maybe it's loading some seed data. Maybe it's warming a cache. Who knows? But there's all kinds of activities that you regularly need to perform in a service, using a service, once you actually have it up and running before it becomes useful. So putting that together into what do you actually need, what are the assets that you need to assemble in one place at provisioning time, these are basically the things. You need all that YAML that expresses to Kubernetes what you want it to do. You need information about your external services, including the location, so that would be hostname, port, maybe protocol, and any credentials that you need to authenticate to that thing. Then application assets. If you're going to load something like restoring from a backup, well, you need your backup data to be available, of course. Or if you just have some initial data you want to load in, you need that available. or if there's often initial configuration that you want for how is this application going to behave, what's its identity, all the normal things you would see in like a file in your etc directory. You need those kind of things at provisioning time. And then lastly, runtime tooling is something that's very important. Maybe you use some sort of template engine to render some of these files we've listed above, like your YAML or your configuration. So that could be traditional config management like Ansible or Puppet or something like that. Or maybe it's Helm that we were talking about a few minutes before I started. And then application clients. If you get a database up and running as part of your, let's say, WordPress deployment that you're doing, you may then need to load some kind of initial data in there and interact with that database. So perhaps you need a Postgres client to connect to Postgres and create the tables and do this sort of stuff, or whatever other kind of work you need to do. So putting that all together, we need all of these things to be present in one place at one time when you do a provision. What kind of technology do we know about that we could use to package most or all of this up into one immutable thing that we can ship around and test and so on? Well, of course, it's a container. Packaging, as a quick aside, I think is the undervalued side of containers. Linux containers are fascinating, and the process isolation piece of it is easy to like get nerdy about and really enjoy. But the packaging aspect, I think, is really perhaps the more powerful side of that coin. So in any case, this container is the MetaContainer pattern. This is the idea of putting everything into one container that sort of functions like an installer for your application in your cluster. So here we've taken this concept and named it a service bundle. You can bundle services together. You get that. It bundles everything you need at provision time into one place. We will take this container and run it start to finish and allow it to exit in your cluster at provision time. It is fully testable and reproducible because it is an immutable image. So you can test it, you can sign it, you can audit which exact version of this service bundle was used to deploy that particular service at that time, whenever that may have happened in the past. And there's more than just provisioning, of course, that we can do here. We could do other operations like backups or upgrades or that sort of thing. But as we'll see, this pattern does have a little bit of limitations imposed by its ecosystem. So now let's shift gears into Chapter 2, and this is the service catalog. Who's familiar with the service catalog in Kubernetes at all, even just that it exists? Okay, that's not so bad. So you're probably all familiar with service catalogs from the likes of Amazon Web Services and other web services. At some point, they figured out that people don't always just want virtual machines to put their workloads on. Sometimes you just want a database, or sometimes you just want a queuing service, and you'd really rather not have to manage it yourself. Maybe, and I can relate to this, I'm a software engineer. I work with software engineers all day. We don't always want to be the experts in how to keep some of those services up and running. I just want the thing to be running and working so I can interact with it as I'm writing my software. So Amazon and others have pioneered this idea of a catalog of services that has grown over, a decade or more now into a very rich collection of services you can just self-service provision and have available to use in their cloud. Well, Kubernetes wanted to offer the same thing. So the Kubernetes service catalog is about that same self-service provisioning idea of getting services provisioned very easily. Here's a user interface that can help perhaps illustrate what that concept looks like. These are icons. This is the OpenShift user interface. You can click through these things, and if you click on one of these, you'll get a wizard of the kind you might expect. It'll ask you questions. How big a thing do you want? What class of storage do you want? What do you want to name it? Whatever questions are relevant to that particular service. And this is how it fits together. So we provide composable services to applications through the service catalog. It's really great for those things like a database or a message service or a queuing service. The actions that are supported through the service catalog start with provisioning and deprovisioning. Those are the obvious ones. But then move on to binding and unbinding, which is a little more interesting. This is the concept of you've created a database, it's up and running, but now you want to connect some other application to it. So you create a binding which tells that database service, please give me that location and credential information that I need to connect to your service. So that's the way of stitching together multiple services potentially. And of course, the power here is self-service provisioning. So we have this client on the left. And this is about the height of my graphical achievements here. And that client talks to the service catalog through some sort of user interface. Kubernetes does not really come with a human usable user interface for the service catalog. And that service catalog has some number of brokers that each advertises to it, hey, I know how to deploy MySQL, or I know how to deploy Postgres, or Memcached, or what have you. And you could have any number of brokers. They could run in your cluster or out of your cluster. You can even do things like in the Amazon cloud, you can install an Amazon service broker, or you can do this in Azure and I'm sure other clouds as well, and get access inside your cluster through the Kubernetes service catalog to native services in that cloud environment, like S3, for example. So it's a really powerful pattern. This is just a quick sort of open source love story aside. All these companies across the bottom have been working together primarily, but a bunch of others have also contributed to produce this open service broker API, which is what makes this whole thing happen. They've defined this protocol. It's fairly elaborate. It's a little bit rigid, but it works really well. And it's been great to be, I've been on a bunch of their developer calls every week and just hear people coming together from all these different groups, trying to solve real tech problems, trying to negotiate and make sure everybody gets what they need out of it, but that we are moving things in the right direction all the time. Okay, let's tie together chapters 1 and 2 into chapter 3. Let's talk about the automation broker. So my team took a look at this broker ecosystem at some point and had the thought, I think we could do something a little better. Maybe trying to figure out how to help people write their own broker as easy as possible is the wrong approach. Maybe we can write one broker sort of to rule them all and make it really easy for somebody to just plug in to that broker and provide a service to that broker. And so here's where we bring back that service bundle idea. You create this service bundle, this MetaContainer, and it knows how to provision a service in your cluster. And this automation broker will advertise that service for you in the Kubernetes service catalog. So if you want to get your application, your service, or even some standard service, but with your standard operating environment or your rules around provisioning, available for self-service provisioning in your cluster, you can do so very easily now by creating one of these service bundles. So they are catalog entries. They run to completion for each operation you run. We set up a secure sandbox. So we create a new namespace. We give it just the permission it needs while it's running, and then we tear the whole thing down when it's done. And it really does remove the need for you to make your own broker. So our automation broker simply looks at one or more container registries that you pointed at and looks for images of this kind that are available to provide these images. So we have a tool that can help you get off the ground with this and get started. It's called APB. Well, I'll explain that name on the next slide. But you can APB init and give it some name. So I chose Lisa here. And it'll give you a skeleton for this container image that you need to create. And it starts with this metadata file that expresses all the basic metadata about your service you want to make available for self-service provisioning. So we have a version, we have a name, a description, some other metadata. And then down about the middle here, we have plans. Plans are, well, you could think of them from the paid world of do you want the free transient one, or do you want the medium one or the large one for whatever metric is important in your service. And then for a plan, you can specify parameters. That's where the real magic happens. I haven't added any here because the screen was only so tall. But you can specify here what input do you need to receive from the user at provision time. So what version of the app do they want? How much redundancy? How much storage do they need? What do they want to call this thing? All that input you need from an installer, this is where you would express each one of those parameters in a rich way so that it can be then later displayed by some client in likewise a rich way. So here's where the word APB originates. We started this whole adventure looking at Ansible as the primary tool for getting this stuff done. So in the Ansible Playbook bundle world, we create one of these service bundles, and we use Ansible inside that container to actually effect change inside your cluster or outside your cluster, which is one of of course, the powers of using Ansible for managing resources in your cluster and workloads on your cluster. It can interact with anything that Ansible can interact with, whether it's in your cluster, off-site, or what have you. So here, the simple mapping is each of the action types that the service catalog supports, like provision, deprovision, bind, unbind, is simply defined as a playbook in your container. You make an Ansible playbook, and you can do anything you want in there, and that's it. It's actually very easy to get started with, and ends up being very powerful. This is the user experience. We're going to go through 3 options. Don't squint too hard. You're not meant to really see anything in detail here. This is just to give you the sense, the feeling, the aura of what it's like to interact with this particular user interface. So if you want to do this from the command line, there's this svcat tool that's available to you. You can get real stuff done with it, but it's kind of hard to wrangle these services using that particular client. Cube apps. This is who's familiar with Cube apps? Anybody have used it? It's more popular, I think, in the Helm community. Great, we got one back there. They do really good work, and they've done some really nice stuff. The last opportunity I had to look at Cube apps, they hadn't really finished baking in all of the provisioning workflow, especially that ability to get the rich parameters 100%. But they've been working on it and making quite a bit of progress. So I would definitely recommend keeping an eye on that. If you're using just plain vanilla Kubernetes somewhere and you want to have a service catalog user interface, I think this is probably your most promising bet. And then the third option you have is the OpenShift user interface. This is far and away the best one, and that's not just because I work on OpenShift. I'd love to see one that's even close to as good. We've just invested a ton of energy and expertise into the user interface of this. So if you're interested in OpenShift, it is totally free and open source, just like the rest of Kubernetes is. I definitely would encourage you to check it out. It is a wonderful and easy way and a very nice experience, especially if you're interested in self-service provisioning. That's sort of what OpenShift specializes in. Okay, so what's the status, like the bottom line on this particular ecosystem before we look at the future? So this is a really great path for you to take for self-service provisioning. If you want today to make some services available inside your cluster, for example, to teams of developers, this is the great way to do it. It does lack day 2 management. Provisioning, deprovisioning, binding, unbinding, even upgrade is all pretty solid, but the Open Service Broker API itself isn't really giving us what we need at this point to do full day 2 management, real active reconciliation, and other kinds of management that we really want to do. So that is a real limitation. The future to alleviate that is going to be this operator pattern that we're going to look over in just a minute. And that said, the service catalog is definitely going to remain part of Kubernetes, I think, for the foreseeable future. It will, of course, be part of OpenShift as well, and it's going to be fully supported for the long term. But there is going to be a shift to this new pattern that we're going to look at over time. Okay, Chapter 4, Operators. Before I tell you what an operator is, let's talk about the Kubernetes API and how you extend it. So we looked at the very beginning at examples of those 2 resources, a pod and a service, that we defined as YAML. Those are primitives that come as part of core Kubernetes, but you can define your own resource types in Kubernetes, and that's called a custom resource. And a custom resource definition is the way you would define some resource of your own. So here's an example I've made of one that represents a memcached deployment. It has the API version and the kind are very important for identifying what type. That is what uniquely identifies in Kubernetes a specific type of something. And then in the metadata, it has a name. The name is like a primary key in a database table. And then in the spec, that's my opportunity to specify what I want this memcached deployment to look like once it's up and running. So in this case, there's just one parameter, and it's a size. It could mean anything you want it to mean. You could add as many different fields here as you want, just like you could with the service bundle. So the operator pattern takes that and fits that in like so. So in the top left here, you have a smiling end user like you and me. And that person, instead of interacting with a Kubernetes service catalog, for example, interacts directly with the Kubernetes API by creating one of these custom resources. So in this case, that smiling old person there would create a memcached resource instance, and in that resource describe what they want their memcached to look like. We're removing here that whole broker ecosystem. We've removed the open source broker API. We've removed the service catalog, and we've removed the whatever protocol you end up using as a user interface to interact with the service catalog as well. We're just using the pure Kubernetes native API, which is very powerful. And we all like simple. So once you've created that resource in your cluster, this controller process notices that it got created and is watching for events related to that resource type, and it begins reconciliation. So a controller in Kubernetes is just a service that runs in your cluster, and it generally owns one type of resource and is responsible for reconciling. And anytime it sees one, ensure that the spec, whatever you've specified, matches the real state of the world. And if not, make whatever changes are necessary to the world to make that true. And in our case, our controller on the other end will spit out whatever pieces are necessary to run your application. Pods, deployments, services, persistent storage, whatever the things you need. And then in our Ansible operator world, very similar. This is in the middle how we fit our pieces together. We use this thing called the Operator SDK, which is a project that helps you get your own operator off the ground, about as easy as we could make it. And in the Ansible case, we have a mapping file. It's very simple. It says, for this type of resource, anytime you see the need to reconcile it, just run this Ansible role or playbook. And that's it. And let that role or playbook do whatever it needs to do. Whatever you've written your Ansible to do, it will run it. And we'll look in a minute at the Kubernetes modules, but the Ansible Kubernetes modules have come a really long way, and they are crazy easy. I mean, it's so easy, and it feels really nice. I really just enjoy managing that Kubernetes workloads using Ansible. If you've tried it in the past, it was not quite as nice. I really encourage you to take a second look. Starting with 2.6, I'm pretty sure, is where the new K8s module became available, and it's just fantastic. And then, likewise, our operator spits out whatever pieces are necessary for your application. So this is the operator pattern. An operator really is a specialized kind of Kubernetes controller that understands how to deploy an application and then babysit it and really take care of it and manage it, all the day two management forever. Active reconciliation, constantly ensuring, did it break? Try to fix it. Do you need to upgrade it? It understands upgrade paths. Back it up periodically. Any kind of advanced leader election or sharding that's necessary. Some services, like maybe an etcd cluster, where you can't just run more processes necessarily. You may need to be thoughtful about keeping odd numbers and adding a new process to the cluster deliberately in some particular way. All that kind of custom logic that like a DevOps-y kind of person, a human would know, that human operational knowledge, we encode into a programmatic service we call an operator. And Ansible is a real nice, certainly a very easy way to get one off the ground for yourself. All right, and Chapter 5 is a quick look at the actual Ansible Kubernetes module. So on the left, we have a Kubernetes YAML file. That is just creating a config map, which is one of the simplest resource types that comes with Kubernetes. You can just hold data in it. It's basically just an object, a dictionary style map. And here I have a color and I've red, because I like red for some reason. Hey, And on the right side, you see the Ansible equivalent of this. This is an Ansible task. And if you're not familiar with Ansible, when you write an Ansible role, for example, or just you want to get stuff done in Ansible, you create some YAML that looks like this, and it's just one task after the next. And each task just does whatever you need it to do. And in this case, we're using the Kubernetes module. We're giving it inline directly. Here's the resource definition, just use it. It's exactly the same as what you see on the left. I did take the liberty of templatizing the color, but I would still make it red. The Ansible template. This is another easy way of using Ansible. So if you want to maintain those YAML files as individual files still on your file system that you can interact in that normal way, similar like if you were doing with Helm. And you're just going to templatize it in the Jinja way that many are familiar with. You can do it just like this, and for this one-liner for each file, it will render that template based on whatever input has been passed into Ansible from the user. And we take care of all that, by the way. I maybe skipped over that part. The Ansible operator takes care of grabbing the spec, all that data that a user specified about what they want the role to look like, and passing that into Ansible as variables that it can use to render these templates or make other decisions. And that's a whirlwind look at workload management with Ansible and other tools on Kubernetes. We have, I think, a few minutes, actually, for questions. So there's a mic in the middle here. Step right up. Oh, thanks.
Hi, this looks like really cool stuff. This is actually a problem that we were actually just trying to solve, which was how do we provide a way for our application developers to just like declare in their manifest, give me a memcached, give me a PostgreSQL, and just builds it. We were looking at Helm because we thought that we could kind of like shoehorn that to work.
Yeah.
How would you describe, because Helm gets like most of the way there, so what are the pieces here? Like, can this work with Helm, or like how does that kind of fit together?
Yeah, it sure can. That's a good question. So Helm is a good tool. Helm is basically a template engine that formalizes a collection of templates into some versioned thing that you can move around and reason about and eventually put into some kind of catalog, right? But so extra value that you can provide through either of these options using Ansible or otherwise is any kind of external service that you want to interact with, any action that you want to take beyond just rendering YAML and stuffing it into Kubernetes is something that Helm isn't really very suited for. You can do that to some extent. You could use init containers. You can perform logic in an init container potentially. Sometimes that's a fine, reasonable way to go. One of the things actually I've played with some, and there's at least 2, maybe 3 videos in our YouTube channel for the automation broker. I toyed with running Helm itself inside of one of these service bundles instead of Ansible. It turns out that works really well. It's very easy to convert. Actually, I've even made a tool called Helm to Bundle that will take a Helm chart and convert it into a service bundle just right away. So that's a nice way to go, potentially. But bottom line, I would say, is that Helm's a real nice tool for what it does. But if you want to do day 2 management, for example, or take some other kind of actions interacting with the database or whatnot, that's not its strong suit.
So you showed some YAML up there where you could say, kind in like, my app or something.
Yeah.
Is that a feature that is already in the Kubernetes API?
Yep,
so we can go look at Kubernetes.io and look at the documentation for that and build against it?
Look up custom resources.
Okay.
And there's some really nice walkthroughs. Yeah, it's really easy to do.
Great. Thank you so much.
Yeah, absolutely. Thanks for coming. Hi.
Cool. Thanks so much for your talk. One of the things I noticed is that your service deployments get sort of run until completion. You mentioned that. Is there any support for like long-running web services that don't really have a completion or anything of that nature?
Absolutely. Yes. So the idea is that the bundle itself, which is like the installer, and if you think of it like a traditional installer, that is the thing that runs to completion and then exits and goes away. But it's expected that it will create long-running services using the native Kubernetes primitives like a deployment or a stateful set that are going to continue to run and do whatever they need to do indefinitely. Does that answer your question?
Yeah.
Awesome. I do have, by the way, I have some stickers. I have Automation Broker stickers. If anybody wants a sticker with that goofy sea monster thing on it, come see me down here in a minute. But yes, sir.
Hi, thanks. I like the idea of self-service provisioning, but this brings up a question. If somebody's going to use your cluster, do you do billing and accounting?
Oh, yes, billing and accounting. The basic answer for the moment is we don't. But both ecosystems have that possibility built into them. So on the service catalog side, the broker side, you would need to make your own broker that understands how to do billing. So for example, if you use the Amazon broker in the Amazon cloud, obviously they understand how to bill you for the services that you provision. So yeah, the automation broker doesn't do that. There is some work happening in the operator SDK. If you go look at the operator framework, it's just github.com, so, well, it's right here. If you lop off the operator SDK part of that last URL, there's an operator metrics repo, I think, that has some interesting things about that that are kind of moving that direction. And there's some other plans, but hasn't fully come together yet. But there's probably a SIG. I bet there's a Kubernetes SIG that talks about that. So I would look for that. It's definitely a hot topic. It's something a lot of people want to know about. One other thing I'll just mention quickly before we adjourn is there is going to be, and there is in development, the same graphical kind of user interface to use with operators. It sort of exists now. It's called Operator Lifecycle Manager, but it's evolving very quickly. Certainly in the next few months, you'll see it available and ready to rock for real. Okay, I'll be up here. I'll hang out and answer more questions. I'll be around the conference too. Thank you all for coming.